On behalf of KLS Gokte Institute of Technology, Belagavi, I extend a very warm welcome to each one of you to the inaugural function of IEEE Global Conference on Information Technology and Communication Networks, GITCON 2025, organized by Karnataka Law Society's Gokte Institute of Technology and technically co-sponsored by IEEE Bangalore Section and IEEE NKSS. Today marks a significant occasion as we gather to celebrate knowledge, innovation, and collaboration in the field of technology and research. To begin this auspicious event, let us invoke the blessings of the Almighty. I now request Ms. Sanika Gurav to render the invocation song. Thank you, Sanika, for this soulful rendition. Every memorable event begins with a gracious welcome. To formally extend a warm welcome to this August gathering, I invite our General Chair, Dr. M.S. Patil, Principal KLS Gokte Institute of Technology, Belagavi, to deliver the welcome address.
Namaskar and very good morning to all present here. Respected members on the dais, Mr. Vijay Kumar Daddi sir, Vice President Research, Process and Sustainability, Mercedes-Benz Research and Development, India. I welcome you sir for this conference. Today's keynote speaker from Thammasat University, Bangkok, Dr. Krinaut Change, if I am spelling it correct. Sorry if I have spelled it wrong. I welcome you, sir, for this conference. Also, the faculty members from the university gracing this occasion. I welcome both the members from the university for this event. Welcome you, ma'am. Welcome you, sir. Dr. Sannaki, HOD, CSE Department. Dr. Kuldeep Samrekar, HOD, CSE, IE Department. Faculty members, students, and the faculty members from and students from other colleges who are present here for this conference, both in presence as well as in absentia. And also Dr. Sonwalkar sir, who is also chairing the part of this IEEE. I welcome Sonwalkar also for this event. I welcome all the members for the IEEE Global Conference on Information Technology and Communication Network. Yes, with the advancement and the research going in almost all the dimensions, 360 degrees with technology, transferring this technology and communicating this technology becomes very, very important. And there is large amount of data and information available now. And therefore, yes, you require the latest technology and the modern technology to process this technology. And in that sense, I think information technology plays a very important role. It is just not informating and processing the information. Finally, that information has to be of some purposes, and that has to be communicated to the people, to the human beings, as well as to the machines, because nowadays machines are also replacing the human beings, and they are part and parcel of any given industry, be it IT industries, between mechanical industries, or be it civil engineering, be it at home appliances, or medicine, or space. This technology has to be shared, to be communicated. And I think the entire focus of this conference will be around this, processing of the information and processing of the data and communicating this data for productive purposes and for the purposes for the safety of the human being as well as our global earth, because nowadays sustainability is also playing an important role. We need to think in all the dimensions, not only growth of information and technology, also how to safeguard our mother earth by using this technology. I believe the presentations, the deliberations, the discussions in the entire conference will be very, very fruitful. Exchange of ideas, lot of networking, so that this conference will have an embark on your mind when you go back and start discussing and have a large amount of connect and move ahead. I wish all the presenters all the best and success for this conference. Thank you and welcome you all for this conference. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir, for those encouraging words. Light is a symbol of knowledge, wisdom, and the eternal quest of truth. To mark the formal inauguration of the event, I now request our esteemed dignitaries to kindly come forward for the lighting of the lamp ceremony. Thank you, sir. I also request one of the participants to kindly join in. As a token of our love and respect, we would now like to extend a floral welcome to all our distinguished dignitaries. I now invite Dr. Mallikarjun Mutt, Professor, Department of Computer Science and Engineering, to kindly present a floral welcome to our esteemed dignitaries. Chief guest, Mr. Vijay Kumar Datti. Guest of honor, Mr. Kritanath Chongnoy. Shri Rajendra Belgamkar, Chairman, Governing Council, KLSGIT, and President of today's event. Dr. M.S. Patil, Principal, KLSGIT, and General Chair, GITCON-25. Dr. Sanjeev Sanaki, Head, Department of CSE, and Secretary of the conference. Dr. Kuldeep Samrekar, Head, Department of AIML, and Convener, GITCON 2025.
Thank you much, sir. Now, I request Dr. Vijay S. Purohit, Professor, Department of CSE, to extend floral welcome to our dignitaries of the dais, our esteemed delegates from Thailand. And Professor Abhishek Deshmukh, IEEE NKSS Chair. To mark this significant academic milestone, we now have the release of conference proceedings. May I request all the dignitaries to kindly do the honors. Thank you all. To provide us with a brief about GITCON 2025, I invite the conference secretary, Dr. Sanjeev S. Sanaki, Head of Department CSE.
Good morning, everyone. Let me start with a quote. Knowledge grows when it is shared, and innovation begins when minds come together. Respected dignitaries on and off the desk, esteemed guests, keynote speakers, faculty members, research scholars, students, and dear participants. It's my privilege to welcome you all to the inaugural function of this conference and to present a brief report on the IEEE Global Conference on Information Technology and Communication Networks, that is GITCON 2025. Organized by KLS Gokte Institute of Technology, Belagavi, and technically co-sponsored by IEEE Bengaluru section and IEEE NKSS. At the outset, I extend a warm welcome to our chief guest, Mr. Vijay Kumar Datti, Vice President, Research Processes and Sustainability Department, Mercedes-Benz Research and Development India. Welcome, sir. are really honored to have you, and we are honored by your presence today. I am also delighted to welcome our distinguished keynote speaker of today, Dr. Kritanat, Data Science and Innovation, Thammasat University, Bangkok. And I am glad to invite, welcome the keynote speakers of tomorrow's. That is, there are two keynote speakers for tomorrow's sessions in their absentia. Mr. Veeraswamy, Technology Leader, Cloud Cybersecurity and AI, Texas, USA. And Mr. Srikanth, Director of Business Intelligence, Clean Tools, Texas, USA. Their expertise will definitely enrich our conference. I also extend a warm welcome to the leadership of our institution, Sri Rajendra Belgamkar, Chairman, Governing Council, KLSGIT, Dr. M.S. Patil, Principal, KLSGIT. Sir, your guidance and encouragement have played a vital role in making this event possible. This year, GITCON has received an excellent global huge response with 1,654 research papers submitted. After review by 487 reviewers worldwide, we have selected 221 papers with an acceptance rate of just 17%. Big round of applause. Highlighting the high standards of conference. Contributions came from 16 countries, including China, Malaysia, Singapore, UK, Sri Lanka, Bangladesh, Australia, Philippines, Thailand, and many more. The conference will host 32 sessions, online and offline mode, led by 34 eminent session chairs, ensuring a rich exchange of knowledge across IT and communication networks. Such participation reflects the growing recognition of GITCON-25 as a leading international platform for researchers, academicians, and industry experts to share knowledge and collaborate. As we begin this 3-day journey of learning and innovation, let us remember that GITCON-25 is not just about presenting a research paper, it's about building networks, encouraging collaboration, and inspiring ideas. On behalf of the KLSGIT and the organizing committee, I wish the conference great success and hope you carry back valuable learnings and collaborations. Thank you.
Thank you, sir. I invite Professor Veena Kangralkar to introduce our esteemed chief guest of the day.
Thank you, ma'am. It is indeed an honor and privilege to introduce to you our distinguished chief guest for today's program, Mr. Vijay Kumar Daddi, proudly leading as the Vice President, Research Processes and Sustainability Department at Mercedes-Benz Research and Development, India. Sir was born in Ilkal and raised in Galgali, a village in Bagalkot district, in a family where education and values were deeply cherished. His father, a retired mathematics teacher, and his mother, a homemaker, played a major role in instilling in him the importance of knowledge and humility. He completed his basic education in Galgali and later graduated in mechanical engineering from PDA College of Engineering, Gulbarga University in the year 1998. From then on, his career journey has been truly inspiring. He began as a faculty member at CAT Center, then moved into product development for FMCG and later to automotive industry. Over the years, he worked with some of the world's most renowned brands like Bentley, Ford, Toyota, Mahindra, and Mercedes-Benz. In 2009, he joined Mercedes-Benz as a technical lead, contributing to full vehicle integration of trucks. By 2012, he was promoted to Deputy General Manager, taking on wider responsibilities. And today he serves as Vice President. With an impressive 26 years of experience in the engineering and automotive industry, Sir has led projects across cars, SUVs, trucks, buses, and even home appliances. He has also championed the use of AI and generative AI in automotive research, keeping pace with emerging technologies. But beyond his professional achievements, what truly defines him is his passion for mentorship. Inspired by his father, he has mentored more than 200 professionals, many of whom are now in leadership positions. His global collaborations with teams in Japan, Germany, the US, and the UK have also given him a diversified and multicultural approach to product development. He is also an operational excellence certified leader and an ICF Level 1 certified coach, proof of his dedication to both innovation and people. On the personal side, Sir is a devoted family member. He is married and blessed with 2 sons. And beyond his busy schedule, he also keeps up with his hobbies like playing cricket, listening to music, and following football. Truly, his journey reflects dedication, learning, innovation, and mentorship qualities that make him a role model for many aspiring engineers and leaders. A wholesome personality indeed. Ladies and gentlemen, with great pride and warmth, I request you to join me in welcoming our esteemed chief guest, Mr. Vijay Kumar Datti. Now I request Professor Seena Kalgatki to introduce our guest of honor.
Ladies and gentlemen, it is my privilege to introduce to you our guest of honor of the day, Dr. Kritinat Chongnoi, a dynamic professional and academician from Bangkok, Thailand. Dr. Chongnoi holds a Doctor of Philosophy in Computer Science, Thammasat University, earned in 2024 following his master's and bachelor's degrees. With over 9 years of rich experience, he has successfully balanced both academic and industry roles. Currently, he works with Planter Group Co. Limited as a programmer and webmaster, where he has developed several innovative software platforms, including solutions that integrate IoT and OCR technologies. In parallel with his industry work, he is also a lecturer at Chandrakesam Rajpath University, where he designs and delivers curriculum in business information systems. His passion for knowledge sharing has led him to be a guest speaker and guest special lecturer at numerous universities and organizations covering topics such as artificial intelligence in marketing, generative AI, and data science. He has also served as an event organizer for major international academic conferences, notably the International Conference on Cybernetics and Innovations, for several consecutive years. His research contributions have been widely recognized with publications in respected international journals and proceedings. His areas of interest include missing data imputation using the Bayes algorithm, recommender systems, and explainability of deep learning models. We are truly honored to have him with us today, and I request all of you to join me in extending a warm welcome to Dr. Kritinat Chongnoi. On a very personal note, sir, we wish you to enjoy your stay and enjoy the vibrant colors of the festivity, Ganesh festivity that is going on in and around our city. Thank you, sir. It is time to hear from our honorable chief guest, Mr. Vijay Kumar Datti. I request you, sir, to kindly address the gathering.
Good morning, everyone. I welcome all the honorable guests and chairman and keynote speaker. It is really an honor to be here. Thank you for inviting me as a chief guest. So they were, asking me what can I speak about this event, and how can I encourage people. I'm too small in terms of the number of years of experience. What is there in the teaching field? This is one of the field which knows only giving, not taking. So to share few things, talking about this event, because this is now currently it is very, very important for us to create these kind of platforms, basically to create awareness about what is happening in the industry and what is happening in the technology, and how these technologies are being used, and
where is the applications, in terms of when you would like to implement these kind of ideas and thought processes. But, I would like to start from the, basics. These are the platforms which are, available, for all of you. But these platforms also should increase, I personally believe, because now what is happening is in the industry is uh, now you are, starting your probably education in engineering, and you are looking at, some uh, technology is upcoming, and you want to, show your ideas and your thought process in that particular field. But by the time you finish engineering, the technology is completely changed. Okay, because now every 2 years things are, changing so frequent. Okay, because the ideas what I had 2 years back won't work after 2 years. But what is more important is, you know, how do you, create these ideas? How do you understand the systems? How do you understand the product? Okay, so that is more important. It's not about, how the technologies are evolving, because technologies are just enablers or facilitators. Okay, but end of the day, what is going to stay is the core idea of the product development, and you know the anything which we do with respect to the systems, or the processes. Okay, so these are required for the industry, because people are becoming so disruptive. They are increasing the speed by bringing these technologies, and they are also pushing to the limit, where everybody keeps talking about maybe machines will replace humans. But I don't agree to this statement. I don't know means how others perceptions are, because more we get into the technology and the innovation, what you need is the brain. Okay, so the computer cannot create its own thought process. Everything is fed by the human. Okay, so I personally feel the more the technology is going to be evolved, the more human requirement is there. Only the thing is, you need to tweak your the journey of learning, where you have to invest your time, where is that you need to focus in terms of your know-how and the knowledge which you would like to get used to. So that is where probably you people have to look into. And what is more important for you is, I personally believe, which I also learned after I finished 12 years in the industry, because till then I was also not having any clue that what my vision is going to be. Okay, so if you want to start something, okay, whether it is innovative, whether it is new technological initiative, but first find your own vision or the purpose. Okay, so if you have the purpose very clear, then you know how to use these enablers to implement. Because if that itself is not clear, because in industry we say that everything starts from why. Okay, so then you can say what and how. Because if why is not clear, so forget about what is that you want to implement. Because otherwise what happens is, we will be like followers. Okay, somebody is moving, somebody is saying now today's technology is AI ML, and everybody will follow AI. If everybody says that data analytics, and everybody will follow data analytics. But see, every industry requires these technologies, irrespective of what the industry is all about. But what is more important is, how do you read the data? Because data is the key for these technological initiatives. Okay, so first look at whether you are able to generate the data, or you are able to scale up the data. Okay, because I have a limited information, but through the artificial intelligence I can scale this data to the level where it can be used for learning, and it can start predicting it. Okay, but end of the day, everything is probability. Okay, probability means there is no 100% guarantee, right? So that 100% guarantee will come from humans. So think about how to make use of, I think these kind of technological initiative. I think I really appreciate Gokte College, because they are taking such an initiatives to give you the platforms, where people are presenting their papers, innovative ideas and thought processes. So maybe, these are some things which you have to start with and think that, where you want to get into and, how do you want to implement them and, where to get this kind of information and the knowledge. Okay, so think in, multiple directions and then define your own, roadmap and say that, this is how and this is the technology which I am going to use it. And I also encourage college to take more initiatives, take industry tie-ups and give those platforms so that the students are benefited. And I see that enthusiasm in Gokte College, and I think my association with Gokte College is for almost now 10 years. Okay, so 2015 is the first time when I visited the Gokte College for campus interviews, and we have so many alumni of GIT in my company. So good to see they are performing. Some of them have gone for a higher education, pursuing their career and the technological initiatives, and see that how can you get the mentoring from the industry and start getting into the idea generation. Okay, so idea generation starts from self within, and you have to start looking at. But what is more important is a collaborative approach. If I say that I only have the idea, but if I come together with many people, that double the benefits of the the ideas. So more the collaborative you are, so more it can be chances of implementation becomes higher, because you will look into multiple perspectives, not in one single perspective. Okay, so I think I'm about to finish 5 minutes. So thank you very much, and I wish you all the best, and I would love to see more such platforms in different colleges, and thank you for having me here, and so all the best, sir.
Thank you, sir, for sharing your words of wisdom and experience with us. As a token of gratitude and respect, I request Sri Rajendra Belgamkar, President of today's function, to present mementos to the Chief Guest and Guest of Honor. Thank you, sir. Thank you for doing the honors. I invite Sri Rajendra Belgamkar to deliver the presidential remarks.
Honored to be in the presence of Mr. Vijay Kumar Daddi. Also honored to be in the presence of Mr. Krutanath Changnoy of Thammasat University of Bangkok, Professor Sannakki, Professor M.S. Patil, Professor Sambrekar. We are very happy to be honored by the IEEE Bangalore section and the North Karnataka subsection to offer this kind of a conference. And I'm very, very delighted to see the kind of participation we are seeing both online and offline. Carrying on with a wonderful discussion I had with Mr. Daddi in the morning, so profound and so succinct. Focus on concepts, strengthening your concepts, focus on studying use cases, discuss those, come up with your own ideas, your own perspective, rather than chasing the maximum salary, which will come your way, it will come. But these basics, if we can follow, so much good will happen to the young minds who are sitting here. Talk to people. All ideas can't be your own. You need to collaborate. Really, really sound advice, and also an invitation to our teachers and our syllabus framers and our leaders who our students follow, to make sure that the pedagogical delivery also evolves and keeps on improving to what the market demands and what students demand and what technology intervenes and demands. I sincerely hope that this conference is one of many, as Mr. Daggi said, one of many that will happen in our college, and our learning and outcomes improve. Uh, Thank you and wish you all a wonderful few days of learning. And we also hope that our guests who have come from Bangkok enjoy our hospitality. Thank you so much.
Thank you, sir, for those kind words. An event of this scale is possible only through the dedication efforts of many individuals working behind the scenes. To express gratitude and appreciation, I now request Dr. Kuldeep Samrekar, convener GITCON 2025, to propose the vote of thanks.
Thank you, Veena ma'am. The future depends on what we do in present. Mahatma Gandhi. Good morning, everyone present here. I, Dr. Kuldeep Samrekar, convener GITCON 2025, feels deeply honored to stand before you to propose the vote of thanks for at this inaugural function. First and the foremost, I extend my heartful gratitude to our chief guest, Mr. Vijay Kumar Daddi sir, VP, Research Process and Sustainability Department, Mercedes-Benz, for gracing the occasion with your presence. Your inspiring words have truly set the tone for this conference. Thank you, sir. A special thanks to our keynote speaker and guest of honor, Dr. Changnai, Department of Data Science and Innovation, Thamissat University, Bangkok, for sparing valuable time from your busy schedule. We eagerly look forward to your keynote address, which will surely motivate and inspire us. Thank you, sir. I would also like to place on record our sincere gratitude to our GC Chairman, sir, Sri Rajendra Belgamkar, whose constant encouragement and visionary guidance have always been a source of strength for us in organizing such events. Thank you, sir. Our deep gratitude goes to Management and Governing Council of KLS for their constant support and trust. Our special thanks to our Principal, sir, Dr. M.S. Patil, sir, for the vision and encouragement that shaped this initiative. Thank you, sir. I also thank Head of the Department, CSE, Dr. Sanjeev Sannaki, sir, for his motivation, leadership, and unwavering support in making this inaugural function and the conference possible. Thank you, sir. A special thanks to all the deans, section heads, HODs for their support and encouragement. A special thanks to IEEE Bangalore section and IEEE NKSS for technical co-sponsorship. Special thanks to the organizing team of GITCON 25 for their tireless efforts in bringing this conference to life. I also thank all the faculty members, staff, student, volunteers, and the technical team whose behind-the-scenes efforts have ensured a smooth and successful inaugural. Thank you. Last but not the least, my sincere thanks to all the participants, delegates, and dignitaries for your gracious presence today. Your involvement adds immense value and sets a promising start to this session ahead. Thank you. As we begin this journey of knowledge and sharing and collaboration through GITCON 25, let me close this with the words, coming together is a beginning, staying together is a progress, and working together is success. Thank you. Thank you once again.
Thank you, sir, for your words of gratitude and acknowledgement. To cherish and preserve the memories of this wonderful gathering, we now request all the dignitaries along with our student coordinators to kindly assemble for a short photo session. Meanwhile, I request all the audience to please be seated as we will be having the keynote address shortly. Thank you, sir, for your words of gratitude and acknowledgement. To cherish and preserve the memories of this wonderful gathering, we now request all the dignitaries along with our student coordinators to kindly assemble for a short photo session. As we come to the conclusion of this inaugural function, I request everyone present here to rise in respect for the national anthem. Darshan, as we come to the conclusion of this inaugural function, Janagana Mana Adhinayak Jaya He Bharat Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravida Utkal Banga Vindhya Himachal Yamuna Ganga Uchchala Jaladhi Taranga तव शुभ नामे जागे तव शुभ आशीष माघे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे Audience, please be seated. Participants, please be seated. Participants, please do not cause any disturbances. Please be seated. Students, I don't want to repeat again and again. Please be seated. It's for everybody. Please be seated. Participants, please do not cause any disturbances. Please be seated. Students, I don't want to repeat again and again. Please be seated. It's for everybody. Please be seated.
For trustworthy AI. Among the key requirements are diversity, non-discrimination, and fairness, with related to bias problem, and transparency, which directly address the black box problem or work and to contribute to these two critical areas. Next, please. To summarize our approach to address the diversity, non-discrimination, and fairness, we propose a novel missing value imputation method using the B algorithm. And to tackle the transparency issue, we propose two methods based on the concept of knowledge transfer. One using a generative adversarial network and another using a B algorithm. Based on this, our objectives are twofold. First, to develop the data imputation method for numeric missing data using a B algorithm. Second, to develop an explainable artificial intelligence model based on the knowledge iteration approach. Let's begin with the first part of our work, data imputation method. So, what exactly is a missing value? In any data set, we have instance with the row, and attribute or feature are the column, right? A missing value often represented by question mark or NA. It's simply a data point is not available in particular instance and attribute. This missing value can occur for many reasons and can disrupt the model training process. Yeah, my work focused on numerical attribute for impute missing value in that area. We call our proposed method as a B-based imputation using combination k-nearest neighbor and linear negation or BKL for short. Okay, next please. Next slide. Yeah, you can next for yeah. Okay. Okay, I think we use the different font with my computer. That is why the image look like ugly. But okay, I will explain my work. Yeah. Okay. The ultimate goal of missing data imputation is to repeat the missing value. So that the data can be used into the maximum potential into building the AI model. Now, imagine we have a data set with missing value P1, P2, and P3 here over there in the red box. Step 1 of my algorithm is we begin by generated initial random solution. For example, we have a S1 and S2 are different set of random value for our missing data point. And step 2, we impute or fill in the data set with one of these solutions. Step 3, we use this now complete data. We generate a prediction model. And step 4, we then test the quality of the model by calculate the accuracy on spread test. Therefore, in this work, we use accuracy as our objective function. We aim to minimize the accuracy obtained from the prediction model that's what trained using the imputation. This accuracy for this example give us 18% or 75%. The quality of the food source in our B algorithm analogy. Next slide, please. This is where the B behavior come to play. Step 5, we have a follower B to select the solution for modify something. Based on accuracy or fitness of each solution, follower B are assigned a solution with higher accuracy like a S1 with 80% will attract more follower B than S2 with 75%. In the step 6, we modify the solution. This is the core of our method. The follower B then intelligently modify the solution. Instead of random value, they use a combination of k-nearest neighbor and linear regression to generate a new more refined value for the missing data. This entire process is repeat, creating the new model and testing that the fitness iteratively improve the quality of the imputation value. Okay. We have a lot of animation. Here are the detail of solution improvement step. For this example, I will demonstrate the process using follow BF1. Follow BF1 has selected the solution from Scout BS1 through the random process based on probability. Then it takes that solution and use it to impute the missing value. Next, we calculate the feature importance score. Our hypothesis is that if a feature has a high importance score, mean it is effective for classification. It should have a higher probability for being selected for adjustment. The selection of feature for adjustment can be calculated using this equation over there. In this work, we use the Gini score. For the example, let's assume feature A1 has the highest probability for being selected at 0.6. The feature selection is done via random selection based on the probability. So from this example, we will select A1 for adjustment. Okay, and in this, the next step, we find the similarity vector using KNN method. Considering only vector that share the same class as the vector we are currently instant in, we select the top K instant, then more similarity to the instant we want to adjust from the search. We find that I1 and I5 are nearest neighbor when K equal to. We then use the data from the neighbor vector to build a ligation model, which will use to predict a missing value for feature A1. A key rule here is that if an instance selected for building ligation model has a missing value in any feature, will not be used in the model creation. As you can see for this example, probability F1 select has now success adjustment the value in position P1 and P2 over there. It's like this. Oh my gosh. Okay. Next. Yeah. Sorry. Go back, please. Back, please. Yeah. Okay. Now let's move to experiment and resolve for our imputation method. On the experiment, in our experiment design, we start with the dataset splitting into training and test set. For training set, we are randomly generate missing value at different percentage from 1% up to 20%. Then we use our proposed method BKL along with several other common imputation methods like KNN, PCA, and SVD to fill in this missing value. Finally, we train a decision tree model on each of the imputed data set and evaluate in classification accuracy on the original complete test set to compare the performance of each method. For our experiment, we use the 3 high-dimension gene expression dataset related to different type of cancer. The first is brain cancer, breast cancer, and leukemia. These datasets are challenging due to the extremely high number of attributes or gene compared to the number of instance. This table shows our main result for our T dataset and across our missing data percentage. Our proposed BKL method shown in the first column consistently achieve the highest classification accuracy. For example, in the leukemia dataset with 20% missing value, BKL achieved 95.1 accuracy, while the other methods are significantly lower, mostly in the range of 60 to 70%. This demonstrates the superior performance for our approach. To ensure that our results are statistically significant, we perform a t-test. The very small p-value in the first row where BKL is compared against our order method are all much less than 0.05. This indicates that the superior performance for BKL is not due to a random chance, but is a statistically significant improvement. In conclusion, for this first part of our objective was to improve prediction accuracy for cancer decision by developing a better imputation method or BKL method with combined with the B algorithm with K nearest neighbor and linear regression consistently achieve higher accuracy score compared to several common methods. In fact, using our imputation data can lead to substantial 15 to 25% in increase in accuracy compared to model training on data imputed by other method. So now let's move to the second part of our presentation, explanatory artificial intelligence or XAI. As we discussed earlier, the black box problem is a major challenge. We have our input data or training set which are used to create a complex model. This model then give it our output, but the reasoning behind is hidden. The goal of AI is try a light on that process to make the model decision understandable to human. Our solution is novel method we call knowledge transfer data synthesis for explainable AI or KTXAI. The core idea is to generate the new synthetic data set that inherit the knowledge from the complex black box model. We can then use this new data set to train a simple model for understanding like a decision tree. All main contribute in this area are follower. We demonstrate how to apply GAN and B algorithm for this knowledge transfer task, which we call KT GAN and KTB. We will show that KTB is superior in synthesis data that truly inherit the teacher model knowledge. Furthermore, the model generated from the KTB dataset are systematically similar to the original black box model. The concept behind our work is knowledge generation. In this paradigm, a large complex core teacher model is used to train a smaller, simple student model. The teacher model provides a soft label which probability distribution over class to guide the student learning process. This allows the student to learn and decision boundary for the teacher effective transfer this knowledge. One of our methods we use for synthesis the data is generative adversarial network or GAN. A GAN consists of two neural networks. The first is generator which create fake data and discriminator which try to distinguish between real and fake data. They compete against each order, and through this process the generator become progressively better at creating realistic synthesis data. This flow chart illustrates or propose KTXAI method. In the first part, knowledge transfer, a student model which act as a generator create the synthesis data. This data is fed into teacher model, this black box model, which act like discriminator. We calculate the loss based on how well get the generated data mimics the teacher prediction. This process repeated until the student effective learner, the teacher knowledge. In the second part, we take the final synthesized data and use it to train the simple explainable model like a decision tree. This brings us to first implementation knowledge transfer using generative adversarial network. In the KT-GAN process, the generator create the data with feature and label. This data is then passed to teacher model. The teacher model predict the label and a probability for generated data. We then calculate the cost entropy loss based on whether the teacher model prediction label matching. The generator original label. This loss is used to update the generator, pushing it to create data that the teacher model will classify in a way that align with intended label, effectively transferring the teacher decision logic. Now for our second move, novel approach knowledge transfer using B algorithm or KTB. The KTB process being by defining the initial information for the B algorithm synthesized data. In this example, let's assume the data we want synthesize has a two feature and two class, dog and cat. When the process starts, each Scout B will randomly generate data for each feature based on defined domain range, and also randomly assign a class label according into the initial information. In this example, we have a Scout B1 and Scout B2. Crucial during the data synthesis, we will fix the class label. That this means the class label will not change during the process. Next, the synthesis data is fed into the teacher model for prediction. From this, we get the prediction result. When the compare the teacher model prediction result with the class label, that's what originally generated, and create a new matching label. This matching label is used to verify the correctness of the teacher model answer, and this information will be used to calculate loss in the next step. From the comparison between the teacher model prediction and generated class label, we will use this information to calculate the loss value, which can be done using the following equation. Let's take the calculation for Scout BS1 and example. We get a loss of 16.6 and the loss of Scout B2 is 83.3. Next, we convert the loss value into fitness function value, which is used to specify the quality of the food source. In if the quality of solution is high, its fitness value will also be high. This calculate using the next equation. When we apply equation to loss value for both B, we get the following fitness score. Then the calculate fitness value is used to determine the probability of a solution being selected for further improvement by a follower. We use this the final equation, the last one, right? In our example, you can see the probability of selecting the solution from scout B1 is much higher than scout B2. Therefore, is in this instance, follower B is randomly assigned improve the solution for scout B1. Each follower B has different chance for selecting a solution through process for random selection based on probability. For this example, we can conclude the quality of the data synthesized by scout B1 is higher than scout B2. In this example, our follower B has randomly selected the solution from scout B1. To improve this solution, we will only adjust the instant where the teacher model predicts was incorrect. In this case, that is a third instant. The next step for improve the solution are follow first. We initial the weight for each feature to 1. On the slide, you can see the header of each feature column show W equal 1. Next, we random select a feature to adjust based on probability calculation from feature weight using that equation. For this example, let's assume feature F1 is selected for adjustment. Once the feature be adjusted, to be adjusted is selected, we will find vector similarity using KNN between the vector with the incorrect prediction and another vector is correct prediction. In this example, we set K equal to based on KNN with K2. We will use instant 1 and instant 2. These instant are then used to build a regression model. The same idea like imputation. To adjust the value in feature F1 of instant we are currently processing. As you can see, we have now updated the solution at the position from 0.7 to 0.4 in the red box over there. This is a hypothesis, hypothetical value predicted by regression model. After that, the modified dataset is fed back into the teacher model for prediction, and we compare the new prediction result with the label to see they can matching. At the same time, we calculate the new fitness function value for improve the solution and adjust weight of the feature that was selected according to the equation over here. We use the exit weight and the difference between the current fitness function value and the previous one. We repeat this process until specified number of iteration is complete, or the loss value stop change. For set number of consecutive iteration, In the next round, the follower B improved solution will have a chance to be selected by new group of follower B, and the scout B will generate a new random initial value. For this experimental evolution for our KTXAI method, we follow this design. We use several public datasets, include Higgs, Jennings first. First, we train the deep learning model for teacher model. Then we apply both KTGAN and KTB to generate the new data at the same size of original and less than original 15% and more than the original one 15%. The KT-GAN use the standard GT-GAN library, while the KTB use the parameter list over here. Next slide, please. This is our dataset detail. And this is our teacher model setting. We use 5 layer and activation function is Lilu. We use Adam optimization and train the teacher model 10,000 epoch. This is our setting for KTGAN and KTB. KTGAN, we use CTGAN library, Python version 0.7.3 with the default parameter. And KTB, we use a number of scout B 20. We have a follow B 100, and we set a K equal 10. We run the KTB 100 iteration. We evaluate the result based on two main criteria. First is completeness of knowledge transfer, which measure how well the synthesis data capture the teacher knowledge, and completeness of explainable model, which measure how similarity result simple model is to the original black box. The first criteria is measured by distribution similarity and knowledge transfer performance, while the second is measured by the Jagged similarity for feature importance. This table shows the R-square value compare the distribution of the synthetic data to the original dataset. A value close to 1 would mean a perfect match. Here, the negative value indicate that both methods generated data with a somewhat different distribution from the original, which is expect since they are optimized for matching prediction, not replacing the original data exactly. However, KTB value are consistency raised negative, suggest its distribution is closer to the original one than KT-GAN. This is a critical result, the knowledge transfer performance or KTP. Measure the percent of agreement between the teacher model prediction and student model prediction on the synthesized data. As you can see, KTB achieved near perfect KTP score, considerably above 93%, often at 100%. In stark contrast, KT-GAN performance is much lower, between 15 to 18%. This demonstrates KTB is far more effective at capturing and transferring the teacher knowledge. Also noted that the size of data set not significantly impacts this performance. Finally, we measure the similarity of the explainable model using Jagged similarity on the top 10 most important features. A higher score means the simple model identify the same important score as a complex model, a black box model. Again, KTB significantly outperform KT-GAN with similarity score often above 0.6 or 0.8, while KT-GAN score are much lower. This proves that explainable model trained on KTB data provide a much more faithful explanation of the original black box model. This chart provides a visual confirmation of our JAGA similarity results using the mini boon NE dataset as an example. The teacher model chart on the left show the ground truth for feature important. The KTB chart in the middle show very similarity ranking and set of top of feature. Okay. In our discussion, we note a few key points. First, data distribution of synthesized data differ from the original because KTB focus on matching prediction outcome, not just replicating data point. Second, the quality of the knowledge transfer is heavily depend on the quality of initial teacher model. If the teacher model bias, that bias may be transferred. Finally, we observe direct relationship between the high knowledge transfer performance and high feature important similarity. The follow B adjust mechanism in the KTB is key improve both these metrics, making is a superior method. Regarding the knowledge transfer performance, this metric reflects the effective of transferring knowledge from a black box model to the synthesis data. It is important to note that if the original training data for teacher model is unbalanced, or if the model is already proficient at predicting one particular class, the knowledge transfer performance will be low. And the effective of the knowledge transfer will decrease. However, if we know about the class ratio used to train the black box model, if it is possible to make the knowledge transfer process more efficient. This also point to a limitation of our proposed method. When the original dataset is static, completely invisible. Now let's discuss the relationship between the knowledge transfer performance and similarity top K feature. A high knowledge transfer performance score directly impact the feature importance, leading to a high JAGA similarity score will. It's clear from the result that the KT-GAN has a low knowledge transfer performance consequently. When its synthesized data is used to create explainable model, that model fail to identify the same important feature as the teacher model. In contrast, the KTB method includes the solution improved step of follower B. The selection with feature to adjust based on feature weight. Therefore, any feature that when modified result is lower loss. In the other word, a higher knowledge transfer performance will have an even greater chance to being selected for adjustment in the future. This mechanism is why JAGA similarity score also increased. creating a much more faithful, explainable model. To conclude, we have a presentation method for creating an explainable to expand black box model through a knowledge transfer process. We apply the principle of knowledge iteration to transfer knowledge from teacher model to synthesized data, and we compare the performance of two synthesized methods, the B algorithm and generative model with GAN. Our experiment involved transferring knowledge from teacher model, which was trained on 6 different datasets, to synthesize data of 3 different sizes, 15 smaller, 15 larger, and the same size with the original one. The result, the B algorithm method is superior in transferring knowledge from teacher model in the term of data distribution. The R-square value for KTB were consistently better. While the paper detailed the specific value, the key takeaway is that KTB data distribution is more faithful. The size of synthesized data did not significant, and most crucial, the knowledge transfer performance of KTB was significantly higher with the average for with average of 98% compared to KT GAN average only 62%, difference over 36%. Finally, we create the similarity where KTB achieved an average score of 0.67, while KT GAN average 0.2. Therefore, we can conclude the performance of knowledge transfer with KTB method is more effective synthesize the new data for a teacher model knowledge. The results explainable model serve as a much more effective and faithful representation the original black box compared to the KT GAN method. Thank you very much.
Thank you, sir, for that insightful session. I now request Dr. Kuldeep Sambrikar to please come forward and present a certificate of appreciation to Dr. Kitanat Jungnoy. Thank you, sir, for that insightful session. I now request Dr. Kuldeep Sambrikar to please come forward and present a certificate of appreciation to Dr. Kitanat Jungnoy. I request all the participants and session chairs to kindly take their lunch. It is arranged in MV Hall. at 1. And after the lunch, you'll be having your sessions. Please go to your respected labs. I request all the participants and session chairs to kindly take their lunch. It is arranged in MB Hall. At 1. And after the lunch, you'll be having your sessions. Please go to your respected labs. All coordinators, can you please come on the stage?